Hello, Benjamin here. Welcome back for another IoT video today about MQTT-SN. So if you're like me, you've heard about MQTT-SN for probably a couple of years actually, but you never got a chance to play with it and you're not sure what it is. So what is MQTT-SN? Really, it's pretty simple. If you take MQTT, you have this very nice, very popular protocol for doing pub/sub and basically publish data or subscribe and consume data. But the thing is that it requires TCP/IP. So what if you are running, well, first on constrained devices and two, on devices that don't really have an IP stack in the first place? What if you do Zigbee or Bluetooth low energy? How do you still leverage MQTT there? Well, you use MQTT-SN. And so that's exactly what we're going to do in this video. And we're going to use the opportunity to use this guy. This is the BBC Microbit. Very cool prototyping, IoT prototyping platform. As you may be able to see, there's it's battery powered if you want, and it's BLE. So what we're going to take is the Eclipse PAHO MQTT-SN library and run it on top of the Microbit. The Microbit happens to have a very nice SDK, by the way, a very complete set of APIs for accessing the accelerometer, the LED matrix that you have here, the GPIOs, etc., etc. And we're going to take some C code, run it on the Microbit, and what's going to happen is that over BLE and over the UART service that's available in the Microbit, we're going to send data over BLE. And what's going to be the other end? The other end is going to be my laptop, on which I'm going to run a simple Node.js app to translate the BLE UART datagrams, if you will, to UDP, so as to forward the data to a so-called MQTT-SN gateway. And the role of the MQTT-SN gateway is essentially to bridge the MQTT-SN network to good old MQTT. So at the end of the day, what's going to happen is that this guy, although it doesn't have any IP stack whatsoever, is going to be able to be bridged to a good old MQTT network, and the accelerometer information of this guy is going to be transmitted over BLE to a gateway to eventually an MQTT broker in the form of the IoT.eclipse.org sandbox MQTT broker. So without further ado, let's jump to the code and let's see how it looks like. So this is my Microbit MQTT-SN project. Maybe a quick look at the config file, where you basically enable, disable whatever features you need on your Microbit. In my case, the only noteworthy part is probably the fact that I disabled pairing, Bluetooth pairing, so as to make it easier to interface to my laptop eventually, just for the sake of coverage. The power, the transmission power of the BLE, of the Microbit BLE stack is going to be maximum, and that's essentially it, I believe. And then, like you can see here, I've basically copy-pasted the MQTT-SN parser, the MQTT-SN library, from Eclipse PAHO in my folder, in my source folder. And what happens next is that I'm going to create my main file. So without looking at the whole code, what's important here is that first we want to be notified whenever BLE is on or off. We actually want to publish MQTT messages when we press the buttons on the Microbit, and that's essentially it. Opening the BLE stack. What is opening the BLE stack? It's essentially instantiating a UART service that we're going to use eventually for reading, writing data over BLE, over the UART characteristics. And back to the main. While true, basically forever, what do we want to do? Get data from the accelerometer. I was mentioning earlier the nice API in the Microbit. Get an example here. Pretty easy to get accelerometer values. That's going to be my payload in the form of JSON. Like I say in the blog post, you may want to look at something else like than JSON, especially since the payloads in BLE are less than 20 bytes. It's actually probably too much to serialize data this way, but let's not worry about it too much in the context of this demo/tutorial. And what's the publish? What's behind publish? This is where the magic happens, I guess. Connection to the MQTT broker if we're not connected, and then sending data. So let's look at well, we could look at MQTT Connect, I guess. We can also focus on publish. The way it works, and that's essentially always the same, you use the MQTT-SN library to serialize into a buffer an MQTT-SN packet, being an MQTT Connect packet, an MQTT Publish, etc., etc. And once you have your buffer, then you transmit it over BLE. So what do I mean by transmitting? Well, it's essentially very, very easy. That's basically making calls to the UART. So for receiving data, you read on the UART, and that's a microbit API here. For sending data, you send the data. That's very easy. Maybe a few more words while we're at it about how MQTT-SN works. And let's look at the MQTT Connect workflow. Connection is very similar to MQTT connection. You specify a client ID, and then you connect. You receive a CON-ACK in return. So you want to look for a successful connection in there. Connection might not be successful. If it is, then we continue. And what do we do next? We register a topic. In MQTT, whenever you publish data, you specify a payload, of course, but you also specify the topic you want to post. And topic is a string. Sending a string every time you publish data might not be the best idea. So what if you were able to register a topic once and for all against the server, and you get basically a short identifier, and that's what you're going to use for publications later on. So that's exactly what we do here. We register a topic that we're going to call microbit / friendly name of our microbit. Could be, I mean, that's something that's basically built into microbit. We're going to see in just a few minutes our friendly name for a microbit we're going to use. And we get a reg-ACK in return. And as part of the reg-ACK, we're going to be able to figure out what's the topic ID that the server attributed to our topic, and then that's what we use when we publish. Back to my publish method, we publish on the topic ID that we've just figured out before, and we publish data, and that's essentially it. So what happens next is that I'm going to use Yoda, which is a toolchain coming from the embed ecosystem, for building my microbit firmware. So let's make sure that we start from scratch. So yeah, again, this is really what you saw earlier, right? On in my code editor, we're going to build the code. So this, if you get the code yourself from GitHub, the first time you compile, it actually fetches the GCC toolchain, and it fetches the microbit libraries, etc., etc. And at the end of the day, what you get is a binary. So as part of the build, I get an X file, and this file is actually what I'm going to deploy to my microbit. So my blue microbit over here is actually running some random hello world code, if you will. And what I'm going to do, and that's where the microbit is very convenient, is just like for embed, I deploy the code to the mass storage. And while this happens, well, of course, you can see that the app on the microbit has stopped for a while. Upload is in progress. And now I'm essentially running a new app. and that's my new BLE MQTT-SN app. So what's missing now is that my microbit needs to connect, needs to figure out how to reach out to an MQTT-SN gateway, and that's going to be done by means of me running on my laptop two things basically. I need an MQTT-SN gateway in the form of RSMB. So let's launch RSMB. That's by means of this command line and this config file. Maybe a quick look at the config file first. RSMB is going to be behaving as an MQTT broker, as an MQTT-SN gateway, and what's more, it's also going to breach the MQTT-SN stuff to IoT.eclipse.org sandbox broker. So that's really all I need. And let's launch the MQTT-SN gateway, and let's launch a transparent BLE UART to UDP forwarder. So what this guy is going to do, and this is Node.js code, it's going to figure out and discover BLE devices in proximity. If the BLE device exposes a UART service, then it's going to breach this UART service to a UDP socket, namely a UDP socket against the RSMB MQTT-SN gateway. So let's launch this guy. Figuring out Bluetooth LE devices in proximity. Oh, one seems to have the friendly name Vivat. Okay, fair enough. And then we can see data coming in, and probably the workflow there was connect, register, and you know the register topic thingy I explained just earlier, and then publishing data. And it seems like things are going well. How about we use MQTT Spy, the good old MQTT Spy, to see if there is data indeed. So connecting to the IoT.eclipse.org broker, looks like that I have a subscription persisted in my settings here. Resubscribe. Oh yeah, we see data indeed. How about we display the data on a chart? You've seen that in my previous video, but just in case, right-click on the message here, show payload values for this topic, and this topic actually happens to be JSON data, and I care about the X value of my data, and that's my data. Let's duplicate the data for the chart for Y and Z, and looks like I have some data flowing now. Let's move the thing. That's pretty cool. And just to show you that we are indeed building a sensor network, and we are indeed completely in a tetherless mode, let me just plug those two guys to a battery. So I have a battery power supply for this one guy, and it's actually already running the software that we've just gone through together just now. Connecting, and what happens now is that, well, I can still see my chart here, but I actually see 3 devices coming in, right? So I could display the charts for all of them, but I don't think that's the point. I think you get what we've done, right? So a few areas for improvement would probably be, like I said before, you may not want to use JSON. That might not be best for the usage of the bandwidth, etc., etc. You may want also to expose other data. I'm actually exposing, like I said, if I press A and B, you should see that as well. And that's it. So pretty cool, huh? So that's what I had for you about MQTT-SN. Like, hopefully you've seen MQTT-SN just works. The community and the ecosystem might not be as mature as for MQTT, but still there's lots of cool libraries that you can use out there for building gateways, for building clients, etc. So let me know in the comments what you thought. If you have any questions, same, just ask. We will be back hopefully in just a few days, maybe a few weeks, still with the microbit. I want to show you how to do firmware upgrades, and the microbit actually allows to do firmware upgrades over BLE, and we're going to use Eclipse Hawkbit for managing the upgrade campaigns, so it should be pretty cool, and we'll see you soon. Bye-bye.